All right, so here's a graphical exercise that I've actually done in another video. But looking over the tests and some of the difficulties some students had, I think it's a conversation that needs to be continued and maybe moved in a slightly different direction. So here's what I'm asking. Let me move Renee the cart down a little bit. Here's what I'm asking you to do. That's what you get. Underline get. When you multiply these two graphs together and start your analysis from the right. So I want you to multiply those two graphs together, and I'm intentionally keeping it vague. Trying to get a certain part of your brain to look at this and another part to shut down. So I'm not saying more than that. Just you got a couple of graphs, multiply them together, and start on the right. Okay. Well, for my money, this is probably the most important video I've made in the last 5 years. I think that the ramifications of it are significant. I'll use the word significant here. All right, so let's slowly figure out how to go about doing this. I'm asking you to perform a calculation. Okay. When you perform a calculation, you got to start with something. I hope you're thinking about it. And pause the video at any time. Anytime I ask a question and you want to give it more time than I give you here, you can, just pause the video and then continue on. You got to start a calculation. Well, I think you start with a number. And I asked you to start over here on the right-hand side. Well, I got news for you. You get to pick the number. Now, I'm not trying to play games here. I'm assuming that, we've got a scale, a 1-to-1 scale. I'm not going to call the number I pick 0.01. I'm not going to do that because this could have been a really zoomed in picture, which is if you're in calculus and you want to understand L'Hopital, you got to do. Okay, so you get to pick whatever you want to pick and describe this number. Well, I hope you say it's big and it's positive. A big positive number. Professor Flynn was here a little while ago, and we talked about this, and he picked the number 100. Okay, you're going to work with 100. What are you going to do? Well, you got to figure out what you get if you put 100 in. And let's say this is drawn to scale, and that's 100. It's about close enough. Maybe it's 75. We also have another number up here. We'll call that one 100. What do you get when you multiply 100 times 75? A much bigger number than the one you started with. Significantly bigger. And I cannot reach that high to put a dot on a piece of graph paper. Just can't do it. Okay. So, how about we pick another number a little further along, maybe 125. Well, that's 125, and what's this one? Well, I hope you say 150 because they appear to be the same amount here. What do you get if you multiply those two numbers? An even bigger number, significantly bigger. So it looks to me like this, whatever we're getting is going up. And very quickly. So, new name for the x-axis. You get to choose. For a high school student, that's great. You get to college, for those of you who are going, you get to choose what you do with your life. There's nobody there watching you. Right now, still watching you. And that's why it's so exciting the end of spring, because that moment when, you don't have to answer to anybody, that freedom. Well, you got the freedom here to pick a number. You do not have the freedom to tell me what you get. And so our new name for the y-axis, what you get. That's our new name. And I know when I pick numbers out here that are big, I've got a positive times a positive, which gets me a big positive. I just started a conversation about sign. We're going to be exploring that in great depth during the second half of the term, especially sign changes. Significant discussion. We're also going to talk about, we'll call this graph that we're getting h of x. We just had a discussion about end behavior. The end behavior. And we're going to talk about limits. And we just did really as x goes to infinity, as we go to the right, bigger and bigger numbers go into this calculation. Where is this function heading? I hope you say positive infinity. You don't need the plus, but I put it there. There are going to be tons of questions branching out of the discussion we're having right now. But it all starts with you understanding that functions, h of x in this case, are calculations. They start with a number. You get to pick what number you want to start with, and you get to perform a calculation. I didn't give you the calculation symbolically. It was on your test symbolically. Now, where else could we analyze? Well, you get to choose. If you want to pause the video, please do. I'm going to tell you where I'm going immediately. I'm going right here and right there. I don't care what you call those numbers. I know what you're going to get when you put it in, right? When you put that number into the function and that number into that function, I know what you're going to get. You're going to get 0. This line is 0. Does it matter what that height is? This line has a 0. Does it matter what this height is? No. In between, we certainly have a what? Sign change. This line went from positive gets to negative gets, which means when I choose a number right here, well, first off, let's get some big dots. We know our graph goes through there. Well, there's this one place where that number and that number appear to have the same magnitude, but one is positive and one is negative. That's kind of like the squaring process. I got a feeling we're going to get something, and I don't know where, but I think there, somewhere in between, we're getting a good size negative number. Yeah. And then over here, well, that y value is negative, that y value is negative, and a negative times a negative is some kind of positive. And we're over here going up. And I think I'm going to get 2 points on the next test because I think I see the graph. Now, what was the question on the test that I gave you that I didn't see a lot of movement on? What was it? Well, let's see. It was the following: sketch. That's what it was. X minus 4. That's a line. Y-intercept negative 4. X-intercept 4 goes through 4, 0. Goes through negative 0, negative 4. And then we had another one parallel to it. That goes through 8, 0. Goes through 0, negative 8. And I asked you to multiply 2 lines together. Okay. Solve the following problem for me. X squared minus 12x plus 32 equals 0. We have those questions on the test. They're standalone questions. Okay, if I put a number in, I get numbers out, but I want a particular number out. And that particular number out is a Y value. And when I don't give you a particular Y value to find, then it's not a snapshot anymore. It's a graph with an infinite number of solutions. This graph has an infinite number of solutions. But we're looking for just one right now. So what are we trying to learn here? If you can factor it, go ahead, and you can. Well, then when you see something like Y equals that, I hope you can replace Y with 0 and know something about what you're looking at. One of the basic skills in math when you're stuck is, when you don't know what you're looking at, can you change the way it's written? Then I hope you would have immediately seen a cup shape up. Anything you show me that is correct on a problem, you're going to get a little credit for. Full credit? Not until you get there. No, not until you actually crack the code. Right? But there are so many topics that come out of this ability to randomly pick a number, to know how to calculate with it. That's why we're doing things like 5 to the negative 2. We had to learn what that means so we could calculate with it. That's why we have exponents like 3/2. We have to learn that that's a square root so we can calculate with it. And if we can calculate with it, we can put enough dots on a board to know what all the solutions look like, the trajectory. So I know that this function has decreasing table values until we hit a minimum. Oh yes, that's another question on the test, finding a minimum value. And you've been trying to work through that. You know, we've gotten a vertex. Well, let's get the vertex of this. If I know it goes through 4 and 8, and I know it's cup shape up, and I have a 4 and an 8, well, I hope you know that the X value you could have picked is a 6 that gets you the minimum Y value. Get, G-E-T underlined. When you get an answer, you show it vertically. Very important to know, because we're graphing 12 different calculations right now. We got linear, quadratic, square root, absolute value, getting into cubics, starting to get into sine and cosine, e to the x, ln of x, exponential growth, exponential decay, and pretty soon, rational functions. Those are the 12 we're going to concentrate on. And if you can visualize a graph, then you can answer a lot of questions. All right, so here's a question to ask. I'm going to ask it and you see if you can deal with it. E to the sine x is a calculation. You actually have the knowledge to tell me what the range of that function is. The only problem is I haven't used the word range that much this semester. Okay, but the range is what Y values are going to come out of this. Now, we have not talked about the sine function very much. Introduction to the unit circle is on the homework. Going to talk about it a lot soon, but the sine function measures height in the unit circle with a radius of 1. So what's the maximum height? 1. What's the minimum height? -1. That's all this thing does. It kicks out numbers between 1 and -1. Okay, boom, 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 boom. There's Yasser again. I saw the clip, the movie clip. That was funny. Thanks for sending that. Okay, and also thanks for the phrase. Yasser used the phrase, because I know that 3 + 4 is 7. I'm going to come over here in a minute, right? But I said 3 + 4 is 5. And he said, in my humble opinion, I think 3 + 4 = 7. And Yasser's right. But more importantly, he wrote, in my humble opinion, which is good for everyone to see. Like there's that is a phrase that you could write a book about. So thanks for sharing that with us. All right, but when you worked with this in elementary school, you didn't get to choose what number you're going to add 4 to. Somebody told you. Well, now you get to choose. You get to choose what number you want to pick. Okay, And if you pick a number, hopefully you have the calculation skills to cube it and to multiply it by 2 and to plot it somewhere on the board. I think that's a fair expectation that if you've got a graph and you're not sure what you're looking at, then you can put some numbers in, get enough dots, and you can draw a picture. I'll draw a picture right now with dots. Oh, you're right. I drew a triangle. I performed 1, 2, 3, 4, 5, 6, 7, 8, 9 calculations, and I was able to see the pattern. Maybe some of you out there said triangle before I did 9. Maybe you did it in 8 or 7. And what's that? That's shortcutting a process so that we don't have to work forever. So what are we studying with all these calculations? All the operations to calculate properly, all the inverse operations to solve equations, which are snapshots of a graph, and an understanding of the trajectory of the graphs we're studying. And we're working towards that. Okay? So it's a work in progress. So there's tons of things that come out of this discussion, and it all boils down to, are you paying attention? Are you thinking about it? Are you working? Okay, so we'll find out because we're going to test again on Tuesday next week. And for folks out there, I will try to do a better job of writing problems. I guess with modern technology, you can move through the video anywhere you want. And I suggest if you're starting to get the first 20 or 30 problems right, maybe you ought to start with problem 31. Save yourself some time, and once in a while, take a test. So it's working knowledge. And we'll keep trying to develop the themes here. All right, but pretty soon we're moving into trig. Pretty soon we're going to learn the speed graph, e to the x and ln of x, rational functions. Well, let's do a rational function right now. Divide the 2 lines, see what you get. Do a division. So instead of multiplication, do a division. By the time I erase this and put it on the board, you're on a piece of scrap paper, draw the 2 lines and say, what would I get if I divided? All right, so take me a minute to put that on the board. And I'm not going to use symbols to represent, even though you know what they are now. All right, so we have a function. And I'm going to divide this graph by this graph. Okay, definitely looking at L'Hopital in a second. All right, I'm just going to look at it. Well, the further I go out, forever. Remember, this is a distance of 25 units. I've got 2 lines that are always 25 units apart. Okay. So I got 1,000,000. I'm putting in 1,000,000. That's my first number. And I'm going to say that this is 1,000,000 out here. Then the upper line is 1,025,000. Division. Do you have a feel for that division? How many times will 1,000,000 fit into that number? And I hope you're saying about 1. Okay, so now we need a scale. Let's actually call that a scale. And I know I have a graph out here that's got asymptotic behavior and y equals 1. Okay, and as I move back to this location, well, that's the smaller value. So that one just became 0 into 25. Well, how many times does 0 fit into 25? I hope you say, well, that doesn't make any sense. Can't perform that calculation. So we got the computer looking, and the computer says, ... I can't find an answer. Okay. So how about when this is 1 unit high? That is 1 unit high. Then this one is 25 units high, or 25 more, so it's 26. At some point, well, I just goofed. What number? Well, no, I didn't really. So what number do I need? Remember, this was an 8. Right? So what number do I pick? I'm picking a 9. Right? picking a 9 because that gives me 1 unit here, 26 units there. And 26 divided by 1 is way up here, 26. So I go from here to here. Okay, and I'm going to erase this section of the graph now. And I always have positive divided by positive, so it's always positive. I can't cross the you choose axis. And you'll find out that you get a graph that looks like that on that section. Yeah, I might as well let you see that. We had the top graph was x minus, no, that's the bottom one. The top one was x minus 4. They're the same lines that I had up a minute ago. So if you put a 9 in, what do we really get? Well, my scale just got blown up out of the water. So if I put a 9 in, mathematically I'm getting 5 units, but it's still going to give us that trajectory. And when are we going to go to positive infinity? The closer I get to 8. So let's get a number really close to 8 right now. 8.1. Minus 4 is 4.1. And 8 minus 0.1 is 0.01. So how many times is that, like the tip of the marker here, going to fit into the marker? Something that small. How many times is it going to fit into that? Infinite number of times. The smaller the number, the more times. So instead of 8.01, I could have done 8.001. Shout out to Steve, our orchestra leader. Very good. Now, what happens as soon as I get on the other side of 8? I'm still picking a positive number, like 7, for instance. But one of my lines gets me a positive, and one of my lines gets me a negative. And if I divide those, I'm getting a negative answer. Huh. Well, what would it be if I picked 7.99999999999? All I get is a sign change. I'd still be near 4. I think I'm down here now. Oops, going the wrong way. Closer I get to 8. Right? Now, I don't know how you're going to get a feel for this graph if we don't work really hard on the ones that you generally put in front of a student sooner. This is one of the more difficult graphs that you do at the Algebra 2 level when you first see it. I believe you should see it sooner. The sooner you start a conversation, the better chance you have of processing things. But we have a y-intercept. Okay, so numbers like, if you pick a 0 for x, then what do you get? Plug a 0 in. Hope you see, get positive 1/2, which is here. Okay, so it sure looks like I'm doing that, which means I crossed the x-axis somewhere and I missed it. All right, I crossed our you pick. All right, so something gets us a 0. Well, I hope we have the skills to be able to solve that. And if I was doing a better job of graphing right now, I'd be going through at x equals 4. So what have I done? I've talked about end behavior again. I've talked about limits. We've talked about asymptotic behavior. We've talked about sign changes. And if I put in negative million here, if I put in a minus million, I got a minus divided by a minus, I'm going to 1 again. Right, that's a crash course with what's called a rational function. Rational numbers are numbers that can be expressed as a fraction, a over b, something over something. Right? Now that's messy, but do I care if you got it immediately? No, because we're going to talk about it every day, a minute here, a minute there. We're going to do one, but not until after midterm. Not going to hold you responsible for that until after midterm. But that's coming up in a few weeks. And we want to try to get, see why I got the hat on. I took a fall. Yep. Legs are no longer working the way they used to. Between knees and hips and everything else. Not much balance from this guy. So that's why I got the hat on. All right. But it's healing. And I wanted you to look at the math rather than that. So hopefully you are. Um, let's see. So what have I missed saying? I put some other things on the board. That's pretty much it. We have inequalities coming, right? When is this function? When is h of x greater than 0? Well, if you got a picture here, certainly when x's are bigger than 8, we're positive, right? And then we're negative from here to here. But we pick up again with a positive at 4, right? That positive. So we're going to be talking about those, solving inequalities. And it doesn't stop. It just more topics bleed into other topics. So it's important to get your foundation down so that you can have those other conversations and have them make sense. All right. So I hope that was an exercise that might help someone. If not, we'll keep talking till it does. Well, like the best thing I was ever told by a teacher was tell them what it is, not what it isn't. Somebody wrote in a comment one time, no gimmicks. Well, honestly, what I heard, tell them what it is, not what it isn't, I live by now. Because I used to do gimmicks, anything to get a right answer. And boy, was I off base. And just keep telling somebody what it is until they understand what it is. And don't tell them something that it isn't. All right, this is what I think is going on, as Yasser would say, in my humble opinion. All right, I think he's got some humility. Not sure how much I got, but I know he does. All right, so I guess that's it. I had my say. All right, we'll keep working. I'll create another worksheet and do a better job of putting the problems on the board. I'll space them out and let you use modern technology. Move around in it, wherever you need to go to make some gains. All right, toodaloo.